Okay, so today I'll discuss one very important topic, that is IAOR, instantaneous axis of rotation. So whenever an object is rotating, then people are not able to find out the axis of rotation is there, right? So this is very important article. Sometimes so many people does not know how to define IAOR and how to find IAOR is there. So IAOR, instantaneous axis of rotation. Axis of rotation. This is very important article in rotational dynamics. So see, first axis of rotation. What do you mean by axis of rotation is there? So what do you mean by axis of rotation? So the point which is at rest is known as axis of rotation, right? So during the motion of a particle, if any point is at rest, so that point is axis of rotation, right? See, when the fan is rotating, so the rod which is giving it support, that is the axis of rotation is there, right? Or we can think, suppose this rod is moving, so the rod is hinged at O. So this point is the axis of rotation. This is the axis of rotation. This is the axis of rotation, right? So if any object is hinged, then that point is at rest and the rest portion are moving. So you can say, if anybody asks you what is the axis of rotation, so you can find out that point is the axis of rotation. Now, this axis of rotation is of two types. So this axis of rotation is of two types. One is permanent. One is permanent and one is IAOR. So what is permanent? When any point is providing axis of rotation and which is fixed, that is by the time it does not change, then it is permanent axis of rotation, right? So in this case, this is the permanent axis of rotation. Or any fan is rotating, so it has permanent axis of rotation. In this case, the same point is responsible for the axis of rotation at all the times. But see, sometimes what is happening, there are certain axis of rotation, it changes with time. So sometimes point A, sometimes point B, sometimes point C. So different points are given axis of rotation at different times, and such axis is known as IAOR, instantaneous axis of rotation, right? So today I'll discuss you how to find IAOR is there, right? So instantaneous axis of rotation. So how to find IAOR? Case 1. So when the object is moving on a stationary surface, in pure rolling motion. So this will be surface and suppose this will be VCM omega, and if you're taking point A, this is point B, this is point C, this is point D. So it is in periodic motion, right? So it is in periodic motion. So suppose the cylinder is in periodic motion. So see, this is at rest, this is at rest. So point C is at rest, and hence in this case it is axis of rotation. See, if when some people does not know, the most of the time they are saying the center is the axis of rotation. Answer is no. In this case, center is not the axis of rotation because they keep on moving. So see, after some time what is happening? The B point will come at that point. Sometimes A point will come at that point, and hence the point always C is not responsible for the axis of rotation. They keep on changing. So this is known as axis of rotation. So point C is the rest, right? So in this case, the point of contact of the object is the axis of rotation. Right? So point of contact is the axis of rotation. Right? Case 2. When the velocity of any two points are known and they are not parallel to each other, right? So the velocity of any two points are known and they are not parallel to each other. So suppose this is the object, any two points, suppose you are taking one V1 and one I am taking V2, right? So these 2 points you know, and then in this case what is happening, draw perpendiculars. So perpendicular to the velocities, this is the perpendicular to the velocities, this is the perpendicular to the velocities. Suppose this is point of intersection. So point of intersection of their perpendiculars. So this point, right? So this point, so O, H, IAOR. Suppose this is your R1 and this is your R2. So since angular velocity must be same of all the points are there, so in this case omega V1 by R1 is equal to V2 by R2. So this is your axis of rotation. So if they are not parallel, draw perpendiculars, or since they are not parallel, so they must intersect at any other point, and then point of intersection. So point of intersection will become IOR. Now I am taking some other case where, so see, now I will discuss the next case when they are parallel. So in the parallel case, again there will be two cases. One is if the velocities of the points are in opposite direction, and if the velocities of the points are in the same direction. So then how one can search IOR is there, right? So next case we are taking case 3. Case 3, when the velocities of 2 points are known directions. So their directions are opposite, right? So see, in this case, what is happening? Two velocities are given. One is in this direction, one is in this direction. Right? So draw the perpendicular. So axis of rotation will be between them is there. Suppose this point is O, this is R1, and this is R2 is there. So see, if they are in opposite directions, right? Suppose if this is there, it is moving in this direction, it is moving in this direction. So if the velocities are in opposite directions, it means what? Axis of rotation will be between them, 2 points are there. So suppose it is at this point O, and this is V1, this is V2. Again, omega will be the same. So we can write V1 by R1 is equal to V2 by R2. So this is the axis of rotation. This is the axis of rotation. Axis of rotation. And if the velocities are in the same direction, so if the velocities are in the same direction, right? So see here, if it will be the same direction, then what will happen? Suppose this is there, it is hinged at that point, it is V1 and V2 is there. If they are in the same direction, then axis of rotation will be outside from that. Also see, V is equal to omega R. So axis of rotation will be always that side whose velocity is smaller is there. Right? So in this case, suppose this is V1 and this is your V2 is there. And suppose let V2 is greater than V1. Draw the perpendicular. So now it will be axis of rotation. This will be the axis of rotation. Right? So suppose this is your R1 and this is your R2. So V1 by R1 is equal to V2 by R2. So in this case, axis of rotation. So in this case, the axis of rotation is outside the points. Right? So in this way, today I have discussed the axis of rotation, which is very important. In the next class, I'll discuss, if you know the axis of rotation, then so many problems of rotation dynamics can be solved easily. Okay. So next time class, I'll discuss the application. If you know the axis of rotation, what type of problems you can discuss. Okay. Thank you.